right, so I'm going to go through and show how I determine the oxidation number for certain atoms, and then I'm going to show you a couple of examples of how to determine what species is oxidized and what is reduced in a reaction. So if I start out, I'm going to start with what I know. I know that oxygen will always have an oxidation number of -2, unless it's a peroxide, in which case it would be -1, or if it's with fluorine, which you'll see in just 1 second. So its oxidation number is -2. Potassium is a group 1 alkali metal, so it will always be +1. So I have already identified the oxidation number for 2 of my 3 unknowns. Now what I need to do is figure out the oxidation number of manganese. In order to do that, I know that the overall oxidation number of potassium permanganate is 0. It has to add up to 0 since the compound has no overall charge. So what I'm going to do here is I'm going to say, okay, my oxidation number of oxygen is -2, but I have 4 of them, which means overall its oxidation number is -8. Potassium has a +1 oxidation number. There's only 1 of that. So potassium overall is +1. So all of the oxidation numbers have to add up to 0. So what would manganese's oxidation number have to be? Well, it would have to be +7 because 1 + 7 - 8 gives us 0. So the oxidation number of manganese is +7. Now the question becomes, okay, if I said, hey, what's the oxidation number of oxygen in this question, would my answer be -8 or -2? And the answer is it's going to be these numbers on bottom, right? Oxygen is -2. Overall, yes, it contributes -8, but each oxygen is -2, each manganese is +7, and each potassium has an oxidation number of +1. All right, let's look at the next question. Carbonate. I know oxygen is going to be -2. All right, so I've got to figure out what carbon's oxidation number is going to be. So I have 3 oxygens, so this is going to be -6. Notice my overall charge here is -2. So what would the oxidation number overall of carbon need to be in order to give me a -2 charge? Well, -6 plus what equals -2? Well, that would be 4 if you did your math. So carbon is going to be +4. Okay. So overall, it has a +4 oxidation number, but since I only have 1 carbon, each carbon will have a +4 oxidation number. So if I asked you to list your oxidation numbers here, it would be +4 and -2. All right, let's look at the next one. Here, I've got Na2O2. So notice this is a little weird. Normally with sodium, we would expect it to be just Na2O since oxygen normally has a -2 charge. So here, oxygen is acting as a peroxide. So this is one of 2 situations where oxygen will not have an oxidation number of -2. So here, oxygen will have an oxidation number of -1. All right. And sodium will have an oxidation number of +1 because sodium is a group 1 metal. So it will always be +1. Oxygen as a peroxide, O2, right? It could be H2O2, Na2O2, whatever it is, it will be a -1 oxidation number. And I can easily check this by seeing that if I look at the overall oxidation numbers, sodium contributes +2 because +1, but there are 2 of them, and oxygen contributes -2. That adds up to 0, which is what I want the overall charge of my compound to be. Okay, let's look at number 4. For number 4, remember, if you look at your rules, fluorine, because it is so electronegative, it will always have an oxidation number of -1, right? Which creates a problem because until this point, other than peroxide, I've said, hey, oxygen has a -2 oxidation number always. Well, it doesn't in this case. This is the second exception. So keep in mind, because I have 2 fluorines here, the overall oxidation number is going to be -2, which means in order for this compound to have no charge overall, oxygen overall needs a +2 oxidation number, which tells us then that each oxygen needs a +2 oxidation number. All right, so that is the second exception for oxygen when its oxidation number is not -2. All right, let's work on some practice with identifying what species or what substance is going to be oxidized and what's going to be reduced in a reaction. So first what I have to do is I have to write out all of my oxidation numbers. So lithium here is by itself, so its oxidation number is going to be 0. For Na2SO4, oxygen is always -2 except for the 2 exceptions we just noted. All right, but overall, because I have 4 oxygens, it's going to be -8. Sodium is +1. But overall, because I've got 2 of them, it's going to be +2. Na2SO4 has no overall charge. So what does the oxidation number of sulfur have to be in order for all of these to add up to 0? +6. So sulfur here is going to be +6 oxidation number. Okay, I'm going to keep going. Sodium's by itself, no charge, so that's going to be 0. Here, oxygen again is -2, but I've got 4 of them, so -8. Lithium is +1, but since I have 2 of them, that's going to be +2. So sulfur has to be +6. Right, so if we look at this, let's look at what oxidation numbers are changing. Lithium goes from 0 to +1. So to go from 0 to +1, what's happening is I am losing electrons. And remember, oil rig. Oxidation is loss of electrons. Reduction is gain of electrons. All right, so it's a nice little acronym. Oxidation is loss of electrons. Reduction is gain. You might also hear Leo the lion says grr. Losing electrons is oxidation. Gaining electrons is reduction. Either way, this is how I learned it when I was in high school. Okay, so since lithium is losing electrons, it is going to be oxidized. Sodium goes from +1 to 0. So to go from +1 to 0, you have to gain electrons. Because remember, electrons have a negative charge. So if I'm becoming more positively charged, that means I'm losing electrons. If I'm losing that positive charge, I'm gaining electrons. So since it loses electrons, that means that sodium is reduced. All right, let's look at one more practice problem. Aluminum reacts with iron nitrate. So aluminum is all by itself, so its oxidation number is 0. Iron nitrate here. All right, so what I like to do, I'm going to show this off to the side here. I'm going to just look at nitrate right now to figure out oxidation numbers. Because as soon as you get parentheses and subscripts, it gets a little confusing. It's still totally possible to do, but it gets a little confusing. So I'm going to just look at nitrate here. All right, oxygen has a -2 oxidation number. However, there are 3 of them, so this is going to be an overall oxidation number of -6. Since nitrate has a -1 charge then, that means that nitrogen needs to contribute a +5 oxidation number. So since it'll add up to -1, those are my oxidation numbers. So I was able to do this off to the side, but those are going to be the oxidation numbers for the atoms that are within these parentheses. So I'm just going to put them here. So -2, this is going to be +5. Okay? To figure out iron, keep in mind, nitrate has a -1 charge, but there are 2 nitrates there. So since overall it has a -1 charge, but there are 2 of them, that contributes a total of -2, which means iron, to cancel out the charge and have no overall charge, iron will need an overall oxidation number of +2. So that's what its oxidation number will be. All right, the same thing happens here. Nitrate is NO3 minus, so the oxidation number of oxygen is -2, nitrogen is +5. But here, since I have 3 nitrates, that contributes an overall charge of -3. So to cancel out that -3 to get no charge overall, I need +3. So +3 will be the oxidation number of aluminum, and iron will be an oxidation number of 0 since it's an atom all by itself. So here, aluminum, notice, goes from 0 to +3. So to go from 0 to +3, you're becoming more positively charged, which means you are losing electrons. So to go from here to here, you are losing electrons, which means that aluminum is going to be oxidized. Oil rig. Oxidation is loss of electrons. So aluminum is oxidized. All right, iron goes from +2 to 0. So to go from +2 to 0, that means you are gaining electrons. So iron is reduced. So one thing that I did want to note at the end of this, if you notice here, your oxidation numbers of 2 different atoms are changing. For a reduction oxidation reaction or a redox reaction, one species has to be oxidized and one has to be reduced. Okay? You might have 2 that are reduced and 1 that's oxidized, but oxidation and reduction have to occur together. Now, if the oxidation numbers of species do not change, if they all stay the same, then the reaction simply is not a redox reaction.